Dear students, up till now we have learned different operations that can be performed in arithmetic logic unit. And today we will be more specifically discussing about arithmetic operations. Although we have discussed in one of the lecture that there are addition, subtraction, multiplication and division, but we have only performed the addition and somehow the subtraction using 2's complement. Then what will be the case that how the multiplication and division will be performed and how the subtraction actually takes place. So this would be discussed in the today's module. So you have already learned that subtraction can be achieved or simulated by addition and negation like in 2's complement. So for example, if we can save numbers in 2's complement notation, like we have stored -3 using 1101, which was actually 13 in binary, and -2 using this. So if we want to add these negative numbers, the answer would be actually perfectly right. And if we want to subtract -5 or we want to subtract 5 from 7, so we can add -5 to the 7. So there is no need for the subtraction circuit within the CPU. One of the way could be to use the addition and storage of the elements in 2's complement notation or in such a notation that can hold negative numbers perfectly. And then what about the multiplication? So multiplication is a repetitive addition. So for example, if we want to multiply 8 with 3, so what we can do 8 plus 8 plus 8. So this would be the multiplication of 8. Or alternatively, we can also do 3 plus 3 plus 3 plus 3 plus 3 plus 3, 8 times, 1, 2, 3, 4, 5, 6, 7, 8. So either we 8 times add 3 or we add 3 times 8. So that would be equivalent to the multiplication of 8 with 3. So this means that many CPUs are built which do not actually have the multiplication circuitry. They are using similar addition circuitry to perform the multiplication within the CPUs. Or this could be one of the way. And then the division, it can be achieved through subtraction. For example, we want to subtract 5 from 15. We want to divide 5 by 15. 15 divided by 5, we want to achieve this. So what we will be doing, we will subtract 5 from 15, that would be 10, okay. Then 10 minus 5 would be 5. Then 5 minus 5 would be 0. So as soon as we receive 0, and we must receive 0, otherwise it's not a whole number. So then we will count the number of iterations we have performed. So in one iteration we have done this step, so it is 1, then there is a second, and then there is a third iteration. So this means 15 divided by 5 will give us the answer of 3. So this is a repetitive division until we reach to the value of 0. However, when we add numbers, whether we are performing subtraction, multiplication or division, you must remember that how that number has been stored actually. If that number has been stored using 2's complement notation, then it is very straightforward. Fetch the value and subtract it or add it or multiply it, whatever. However, if it has been saved in floating point notation, then you must remember that in floating point there is a sign bit, there is a mantissa field, there is an exponent field. So first you need to extract the mantissa, then you need to see the exponent, and based on the exponent field you need to move the radix point or the decimal point within the number, and then you need to see whether the number is positive or negative using the sign bit. So this means in such a case, the addition would be totally different. So it also depends that how the values have been saved. So if we conclude today's module, we have learned that how arithmetic operators, more specifically the addition, can be used to perform subtraction, can be used to perform the multiplication, and how subtraction can simulate the process of division in computer science.